So, unsaturated fats are normally found in vegetable oils and fish, and they're recognized to have beneficial health, right? Things. One of the ones that you'll hear about is called omega-6 fatty acids. It's called omega-6 fatty acid because there is a double bond at the 6 carbon starting from this end. Starting from the non-polar end, not starting from the carboxylic acid, starting from the other end. I know that doesn't make much sense. We would normally start numbering carbons from the other end. In this case, you're going to start from this end. So the omega-6 fatty acids have at least one double bond, and the first one is at the 6th carbon. You may also hear about omega-3 fatty acids, and they come from fish. So if you take fish oil, some people give fish oil to their dogs, some people take it themselves. It's supposed to be good for you. Is omega-3 fatty acids. So where do you think the first double bond is?
On the 3 carbon.
At the 3 carbon, right? So, and somebody in the other class said, oh, is that why if you drop a fish oil thing into water that it looks like there's a film on top of the water? Yeah, it's a fatty acid. So is it soluble in water? No. So when you try to dissolve that fish oil in water, what happens? It just floats. Just like vegetable oil, right? Same
You
kind of
know
thing.
what is interesting that you mentioned that, because I'm a dog groomer, and I had a terrier recently come in that needed hand stripping, and the customer was feeding it fish oil as a supplement, and I could not strip that coat because it was too oily.
Yeah, because they'll excrete the oil in the coat,
Mm-hmm.
and we're going to talk about that in a few minutes. So there's like if you look at when we talk about waxes, this is an oil, but waxes are what's normally on a dog's coat. It's a waxy substance, but that dog is probably just excreting the oil through its skin, and it's on the coat.
Yeah,
Just get
it
so
felt
much-
like somebody rubbed a handful of lotion all over
Yeah,
the fur.
yeah.
I mean, you couldn't even separate the hair.
Yeah, we used to, when I used to show dogs, we used to give them fish oil. It makes their coat nice and shiny, or raw eggs. So, now, what is arteriosclerosis and heart disease are forms when you have too much cholesterol in your blood normally. The cholesterol, it forms a plaque that sticks to your arterial walls. This raises blood pressure because it's constricting the flow of blood, so your blood pressure goes up and can cause heart attacks, right? If you get enough constriction of the blood vessels on your heart. The omega-3 fatty acids tend to lower the blood platelets' ability to stick together, so it's thought that they help reduce this plaquing kind of thing, and so it helps to clear your arteries a little bit. We're not gonna worry about this. Now waxes, what are waxes? They're natural fatty acids. They're found on the surface of leaves, plants, and they help prevent water damage from pests. They also help prevent water loss. They also play a role in structure too. Waxes can be quite rigid when they dry, and so they help the plant. So anybody ever seen a really shiny plant leaf? If you go over and touch it, it feels kind of waxy feeling, right? Almost like a candle, right? There are some plants where you can go scratch them and you can see the wax on the leaf. Okay, so this is beeswax, another example, right? They produce this as a structural thing, right? So waxes on skin, fur, and feathers of animals provide a protective feeling, like the dogs you're talking about, like a Portuguese water dog. I bet if you felt I've never been around Portuguese water dogs, but I bet if you feel their skin, their fur, that it feels very like slippery because it has wax on it. It prevents the water from making the coat wet, right? Or what are other good water dogs, like Chesapeake Bay Retrievers or Nova Scotian Tolling Dogs or something like that. See, I know my breeds.
Golden retrievers are water dogs.
Yeah, but golden retrievers they're just idiots.
That is so true.
I don't like them.
They're just giant dudes.
Yeah, they're just like, yes, I'll do whatever you tell me to do. Thank you very much. Right?
Anything from the movie Up when you said that dog gets like a golden retriever and he's stupid.
That's all they do. I do whatever. Yep. Okay, go give me a treat. Like it. So, waxes they're a little bit different than the other fatty acids we were talking about. And they contain a fatty acid with the carboxylic acid, but at the carboxylic acid, there's a long chain alcohol on the other end of the carboxylic acid. So this is no longer a carboxylic acid, it's now an ester. with a long chain alcohol at the other end. And that's what makes it a wax, right? These are all solids at room temperature, right? Because you have a fatty acid and you have a long chain alcohol. So you have two things that are long chain carbon chains that tend to be solids at room temperature, okay? Don't get so hung up in the details here. In the body, in your body, fatty acids are stored as triacylglycerols. Triacylglycerols are esters of glycerol and fatty acids. And the tri means there are 3 fatty acids to go with the glycerol, okay? They're formed when the hydroxyl group on the glycerol interacts with the carboxyl group on the fatty acid. So here we go. Here we start with glycerol, and then we have 3 fatty acid molecules right here. Right? So here's our glycerol with 3 hydroxyls. Here's our carboxylic acid groups. And this is an esterification reaction, right? Just like we learned about before. Now we make this ester over here. We have 3 fatty acids joined to this glycerol molecule. Okay? Now note that this fatty acid is saturated. This is how your body stores energy. Why do you think it's important that this fatty acid be saturated? Does your body store energy in fat?
Yes.
Yes. Does it store that fat as a liquid?
No.
It stores it as a solid. What is a solid at room temperature, or even above room temperature? Saturated fats. So all my fat is saturated fat, storing energy. Right? And that's how I store it. Lots of energy in a small space. This is just a different or a mixed triacylglycerol. This is not how your body stores energy. It has 3 different ones on there. We're not going to worry about it. Why is that important? It allows you to store lots of energy in a small space. If you're an animal that hibernates in the wintertime, you're going to eat lots of foods that are high in fats so that you can store that energy. And then when you hibernate, your body accesses that energy. How do we access that energy? We'll stop eating. And your body will stop burning the sugar that you're eating. It'll start burning fat. So what I need to do is sleep for like 6 months, and I can lose all this. That's a win-win situation, I think.
So you need to go into a coma.
I need to go into hibernation. What do y'all think? That'd be good, huh? Come out, be like that thing. We don't hibernate, unfortunately. This guy does, though. He's cool.
Saying, hey, what's up?
Anybody ever seen a polar bear in the wild? Anybody ever been anywhere where they have polar bears in the wild?
Zoo.
That's not the wild. You gotta go to the wild. Not Madagascar, you gotta go north. I was on a ship one time on a research vessel. We were up above the Arctic Circle and there were polar bears,
That's awesome.
which is pretty cool. Very inquisitive, very agile, very nimble. I would not want to be in the water with this guy. They're incredible athletes. As big as they are, the ice was kind of broken up and they were just like bouncing from one piece of ice to the other. Like it was nobody, like no big deal. The ice was moving, just, I'm like, whew. And they're big. They're very big. We're not gonna worry about naming fatty acids. We're not gonna draw structures. Boom, boom. Okay. What's the difference between a fat and an oil? Normally fats, in general, fats come from animals. Oils come from plants, in general, okay? So fats are solids at room temperature. Sources are meats, whole milk, butter, cheese. Oils come from plants, like palm oil and coconut oil, right? So when you buy sunscreen and it has that nice coconut smell in it, it also contains coconut oil, right? You okay over there? Hey lady, are you all right? No? We Will you call 911 for me?
No, that's not that drastic.
So oils from olive and peanut oil are monounsaturated, so they can contain large amounts of oleic acid. These other oils may contain fatty acids with 2 or more double bonds. Palm oil and coconut oil are solids at room temperature, so they contain mostly saturated fats, right? Bless you. Melting points. We've already talked about this. The more saturated you are, the higher your melting point. Okay? If you have lots of unsaturated fats in you, then you're going to have a very low melting point. So olive oil, that's what they have right there, right? Olive oil is a monounsaturated fatty acid, so it's a liquid at room temperature. Because look at those tails, they don't exactly stack up. If you bring another molecule in next to it, it doesn't stack up too well, right? Because of those bonds. And we already talked about how you get to Crisco from vegetable oil. Hydrogenation. Add hydrogen, get rid of the double bonds, make it saturated. That will make it a solid at room temperature. Yeah, we already talked about this. Some foods naturally contain trans fatty acids, which mean that the trans doesn't put a big kink in it. It still looks relatively straight, and therefore they will still be solid. Foods that contain trans fatty acids from the hydrogenation process, all these kinds of things. Deep fried food, because the oil that they use is normally a hydrogenated vegetable oil, and turns it into trans fats. Don't worry about that or that. What kinds of reactions do these fatty acids undergo? Well, this is our triacylglycerol, and then it has 3 fatty acids. It's an ester. What kinds of reactions did we talk about with esters the other day? We talked about hydrolysis, acid hydrolysis, where we break this apart and we make 2 alcohol molecules. Didn't we? When an ester breaks apart under acid conditions, you make 2 alcohol molecules. Where do you think this process might occur in your body? If you were to eat a fat, where do you think this would occur? It's going to occur in your stomach, right? Because your stomach is acidic, isn't it?
Yes.
And you have digestive enzymes called lipases that help break that apart. Okay? You could do base hydrolysis or saponification. This is how you make soap. Remember the other day we talked about the clantins. Granny takes her lye and her possum fat and she cooks it. She is breaking apart that bond and releasing the fatty acids so that they can then join together to make soap. She's making the salt of the fatty acid. Instead of now this part over here, remember under acid hydrolysis, this part was just another alcohol molecule, right? Now it's not an alcohol, it's a salt, positive and negative. It's ionic. Because it's a salt, these things tend to be solids at room temperature. Okay? This is how you make soap. If you go buy some fat or some oil and you add base to it and heat it up, cook it, you can make soap. Fair enough? And this table really does a good job of summarizing the 4 reactions with fatty acids. The first one's esterification, when you make the triacylglycerol. Then we have hydrogenation to get rid of double bonds. Then we have hydrolysis and saponification. Saponification really is just, instead of having acid hydrolysis, we have base hydrolysis.